Okay, today we're going to talk about symmetry, and I bet some of you already know something about symmetry. Can anybody tell me what the word symmetry, having symmetry means? Even on both sides, very good. That is a nice way of putting it. It's that symmetry, there's actually more than one kind of symmetry. And the one you're referring to, Darylyn, would be line symmetry, which is when you can cut something in half and fold it on that line, it matches. So we sometimes like to think that our faces are symmetrical, but they're usually not perfectly symmetrical, but they are pretty close. So this butterfly has symmetry. Now, of course, you have this picture on your paper, but you can't have a moving object on your paper. So this is kind of cool looking to see it, that when the butterfly closes, its wings match up. And its body has symmetry as well. It has two antennas. So a line of symmetry or reflection symmetry. A figure has line symmetry if the figure can be mapped onto itself by a reflection line called the line of symmetry. These are things you have to fill in on your worksheet. Some figures have no line of symmetry. Some you can't cut in half, and some have only one, and some have two or more, okay? The butterfly has one, all right? One line of symmetry that cuts that butterfly in half. Not that I want to cut him in half, but. Okay, anybody still need this for filling in? All right. Now, you don't have these on your page. I just want to show you about some lines of symmetry. Some letters have a line of symmetry. A has a vertical line of symmetry. B has a horizontal line of symmetry. Murphy, you not do that for me. This has two lines of symmetry, a vertical and a horizontal line of symmetry, the X. The word mom can be split in half right here and map onto itself. If you folded, the M's would match up and the halves of the O's would match up. The word heed has a horizontal line of symmetry because each letter in the word heed has a horizontal line of symmetry. A square, how many do you think that is? It looks like more than it actually is. It's only 1, 2, 3, 4, okay? A triangle, 3. And why? Because it's equilateral. So if all the sides are the same, that's what's true about a square and an equilateral triangle, then they're going to have as many lines of symmetry as they do angles or sides. If you look here at the rectangle, though, it only has 2. And you might say, well, why isn't this one? If I went on that diagonal, oh no, I didn't hit the center, and I can't, I'm going to show you with a piece of paper, but I can't do that for the video. I would fold, if I folded on that line, this corner is going to go up here. And this corner is going to come down here, and they're not going to meet. That's why that's not a line of symmetry. Okay, and that's going to be real important. So if I physically show you how you could remember, you take a rectangle, like a piece of paper, and you fold it in half. See how it doesn't match up? Okay, that's why a parallelogram and a rectangle do not have a line of symmetry on the diagonal. So I'm going to show you about the parallelogram too. So the case of the parallelogram, does a parallelogram have a line of symmetry like this? And the answer is no, because if you folded it, again, this point would go up there, that one would come down here, and they showed it right here. Fold it in half, it's not a line of symmetry. Okay, so now we're going to talk about another type of symmetry that you might not have been aware of, which is rotational symmetry. A figure has rotational symmetry if it rotates onto itself before it has completely turned around a point. So anything can be turned around 360 degrees and it's going to land on itself, all right? But if it has an angle before 360 that it will land on itself, then it has rotational symmetry, and then you're going to figure out what that angle would be. Bryce? Hello? The number of times the figure maps onto itself as it rotates from 0 to 360 is called the order of symmetry. You have some things to fill out. The magnitude of the symmetry, or the angle of rotation, is the smallest angle through which a figure can be rotated so that it maps onto itself. So that figure right here, if you turn it, so I'm going to start at the top, and I'm going to say, well, wouldn't it turn and land right there and be the same? Okay, how many times around could you go? So I'm counting 1, 2, 3, 4, 5, 6, 7, 8. So this would have order 8. Okay. And now I want to get the magnitude of the angle or size of the angle that would make it land on itself. So the magnitude is going to be 360 divided by 8. Because I want to find out how many turns, and I can even show you where the angle would be coming from by showing you this. If I go up to here, I'm trying to figure out what the angle would be to make that point go to this point. And the way to get it is say, how many turns can it make to keep going? And we just figured out that that was 8. That's called your order. And then we'll figure out the angle by taking the 360 divided by 8. What'd you get? 45 degrees. Okay, so it has magnitude of 45 degrees and order 8. Those are two things you're going to have to be able to answer. What the magnitude is and the order. You will find the order first and then figure out the magnitude. Do you have another diagram on there? You don't have an arrow. No, I think I did that. Okay. So I'm going to show you a quick place at a website that is going to do something kind of cool. It has you a visual of the order. Why is this order 2? It's because it takes 1 turn, it lands on itself 2 times till it's back on top of itself where it started from. Okay, so this has 2 pieces. The order is 2. What would the magnitude be then? Well, it would be 360 divided by 2, and I can't really write on this because I'm at a website, but that would be a 180 degree turn. Check this one out. Why is it order 3? 1, 2, 3 turns till it's back where it started. So you could do 360 divided by 3, which would be a magnitude of 120. Okay, now I'm going to show you down here several pictures of different types of things. All of these are order 2. Got a propeller, sort of I don't know, don't see too many of those, but the S and this one. These are going to have a special thing called point symmetry because they're exactly a turn of 180. Order 3, all these are examples. Order 4, and there's one that's order 8. So it can keep on going. It can go on and on and on. All right, so there's more of them. I think that's enough of those for us to be able to. Dartboards, these are real world examples. This has rotational symmetry, order 10, okay, because every black one, if it got back to another black one, there would be how many black ones on here? There's 10 of them, and there's 10 white ones, and so that's why it's order 10, and you could divide 360 by 10 and find out there's 36 degrees between 2 of those. Metals. You noticing any other types of symmetry in here? There's line symmetry and rotational symmetry. Ferris wheel has rotational symmetry. You'd count up all the cars on it. Now, I could do some more from here, but I think we'll get back to our paper. So, what the point is, there's a lot of places with symmetry in the real world. We like symmetry. You see all these things? These are different logos. Do you know what that one means? Recycle, right? This is just some crazy, I don't even know where that came from, but it almost looks like middle part's underwear, but it's kind of strange. I don't get it. It's a three-legged thing, but there's tons of symbols. This is Department of Transportation. tons and tons of symbols. Why do you think they have symmetry? We like it. Okay, we like it. We like seeing symmetry in things, whether it be rotational, spinning symmetry, or so most of your designs, a lot of designs have different types of symmetry in them. Drawing, I know if you're in art class, you probably know a lot about the ideas of symmetry. All right, point symmetry is special. It's when a figure can be mapped onto itself by a rotation of 180. So you're going to need to know that that's called point symmetry. It looks the same upside down, okay, or from any two opposite directions. So check out this jack. A lot of people have not played with cards these days, I realize. How many of you never played with cards before? Deck of cards? Anyone? Oh, well, no, maybe you don't want to say if you didn't, but it's not like a bad thing, but I hope we do know about some of the cards at least, or have been exposed to them and all. This is a jack of clubs. Check this out. If I rotate it, I did 180 flip. It's right back on top of itself. So this thing has point symmetry because it looks the same right side up as it does upside down. Lots of several, well, the queens also have it, the kings, okay, in the deck of cards. Pardon me? Oh, go ahead. I think they all do, don't they? They're all turnable to go upside. Well, I have to look. Anyway, state the figure, whether the figure appears to have line symmetry. If so, draw all lines of symmetry and state the number. This heart has line symmetry. It would have only one, okay? So that's what it means when it gives you those directions. Rotational symmetry is when you can spin it. Now, this one has both line symmetry and rotational symmetry. But if it says state whether it has rotational symmetry, you want to give the order and the magnitude. So this one would be order 4. Okay. You then take 360 divided by 4 and get its magnitude is 90. Now I can show you that the center of the symmetry, you might guess that it's right there. The reason it's right there is if you drew in the diagonals, and the diagonals go from a corner to an opposite corner, we would pass right through that center. That's the center of rotation. You can find it by drawing in the diagonals. Now we're going to do some examples together. State whether the figure appears to have line symmetry, right? Yes or no. Now we're looking for line only, not rotational right now. If it does have line symmetry, then we're going to draw all the lines of symmetry it has, and we're going to state the number. So this first figure, how many lines of symmetry would it have, or does it have any? Yes, so it's a yes, and you're telling me 5. Okay, and you're right. We would need to draw all 5 then. So you can use a ruler if that would be helpful for you. I have a tool that can make mine nice, or you can be sloppy, which I'm going to go ahead and try the sloppy way. So meaning I'm not using a straight edge because some of you don't have one. Okay, so if I went through the top, through the midpoint of the bottom, that would be cut in half. I got to go from each corner and do that to the middle of the other side. And this, I'm only expecting you to be able to show this to me just like I'm doing it. It's not going to be necessarily perfect, so I had a crooked one right there. Okay? Those would be your 5 lines of symmetry. How about Mr. Happy Face? So it's a yes, and it's only 1. All right, straight down between the eyes and the mouth. How about Z? Where can you chop it and make it fold so that it lines up to itself? Because I heard some people say yes. Does it have? Okay, okay. If I draw a line like that, will this go on to the same thing on the other side? No. Okay. Does anybody think there's a way you can cut it? Can you show me one? You can't do it. This one's a no. There is no line of symmetry for this figure. Now, it does have that other symmetry I told you about. If I spin it, it would have order 2. And it would rotate 180. So it would have point symmetry. But we're not talking about that right now. We're just talking about lines. You got to remember what the question is asking. All right. This rectangle will have yes and how many? 2. Only 2. Because you can only cut it in half vertically and horizontally. You cannot go over it diagonally. Now, I agree the diagonal cuts it into 2 congruent triangles. However, it will not fold on that line. So it's not a line of symmetry. All right, now the next question is actually asking you, and I know you guys had to flip your page, to state whether the figure has rotational symmetry. We got to write yes or no. And if it does, then we have to locate the center of symmetry, state the order, and the magnitude. All right, it's already got, this thing's a yes, right? You obviously can spin that thing. Okay, the center is right where the dot is. So I really didn't need to find it because it's there. How about if I wanted to spin it? We always go counterclockwise. So how many do I get to spin it till it gets back to the top? 8. Okay, that's your order. Okay, so this is order 8. And the magnitude, we just abbreviate magnitude, M-A-G. Let's take 360 divided by 8, and we get 45, right? 45 degrees. Okay, number 6 looks like an old-fashioned phone's handset, kind of. It's the same on the left and the right, but can you spin it? I could cut it in half with a line of symmetry, but I cannot spin it. If I spin it upside down, it won't look the same. The only way to spin it is to go all the way back around, and that's just not rotational symmetry. So this is a no. Okay, what about 7? Does it look the same upside down as right side up? Okay, let me try it. I just turned it over. Was it the same as it was? Yes. Okay, that's the kind that has point symmetry. So this is a yes. It is order 2. And the magnitude is 180, which means it has point symmetry. Point symmetry is a rotation of exactly 180. Number 8 looks pretty good, right? These all match, all these little pieces. So I can see that I could keep turning it, and so it's order 1, 2, 3, 4. And what would the magnitude be? How big? 90. Thank you. Yep, 90 degrees. All right, you guys have practice time now. So I'm going to give you till about 1/4 to do some of the practice. And yes, I know my 1 through 3 are missing. I'm going to insert them in case you want to ask me on something. After that, we're going to go to the ISM. Did you have a question? Guys? Did you have a question, Kylie? What do you need?